Okay, welcome. This is new for probably all of you. So there's a group of us here. Hopefully everyone can make it. Let's see how many we have. We have 12. We're supposed to have 22, including myself. Actually, I think I might be in there twice. I'm not even sure. Because I was having issues. In fact, this is computer number 2 because computer number 1's microphone wasn't working. So that's why it took me a bit to get started. So let me talk about what we're going to be doing today, and I'm going to share my desktop with that. Okay, so you should be able to see, and let me make sure I can see the chat. Somewhere in here should be the chat. One more time. Oh, maybe because no one's chatted, but I think people chatted. I'm a little worried about that. I can't see the chat, but again, you're welcome to talk. So again, mute yourself and then unmute yourself when you want to talk, and then remute yourself when you're done talking, and that way we don't get any feedback and that kind of stuff. So this is the Math 107 class, and I want to let you know this is different, and I think you all understood that it was going to be different. And don't get mad at me for this because I'm not the one that caused it. It's just stuff happens. So this is actually the first time I've ever taught this one as a somewhat online course. We're calling it an Eve course, as we'll see in a bit. And I want to start out by just telling you what the plan is for the next almost 2 hour and 40 minutes. What we're going to do is we're going to start out by, I'm going to go over the syllabus and talk about what this class is going to be about and how it's going to proceed. Again, there's a lot of new stuff for me too. So I'm doing the best. I've taught online for decades, but I haven't taught this class online. So there's going to be some new things that I'm experimenting with, and I'll have to get your feedback and see if it works. I'm not going to spend the whole time talking about just how the class is going to proceed, because you're calculus students, you can handle that. I want to get into math. So what we're getting into, and some of this might be review, some of it won't be review, depending on where you had it pre-calculus. But we're going to be talking about parametric equations. So I'll talk about why you care about parametric equations. I'll talk about what the definition of a parametric equation is. We'll talk about how do you graph a parametric equation. And we'll also look at how do you get a regular equation, a function of y in terms of x, and then turn it into a parametric equation. And then how do you take a line and make that a parametric equation? How do you take an ellipse or a circle and make that a parametric equation? And other things, other functions we might want to, or not functions that we'll want to make parametric equations out of. We'll talk about eliminating the parameter, which basically that is starting out with parametric equations and turning it into the good old y equals x form. And we'll talk about how do you look at intersections and understand intersections of two parametrically defined shapes. So that is the plan. And I'm going to mute people because we're getting some feedback. But again, if you want to talk, unmute yourself. And you're always welcome to talk. If I can mute you if you're not on a phone. Let's see if there's anyone else. Okay, are there any questions at all? Any questions at all about anything so far before I get into the class? Okay, why don't I walk into the class? So in the class, I'll get the wrong one open, but I'll get the right one open in a minute. This is the wrong class. There we go. Okay, so this is Math 107. And it's really a new way, first time ever in the history of the world doing 107 this way. And it's not because I decided to get creative and, you know, it's like I hated the other way, so let's go to this way. It's because we're not allowed to go back to the college. So in fact, we're calling it in enhanced virtual environment. And I'll use the word EVE for that, EVE for the acronym of that. And we're going to meet Monday, Wednesday, Friday from 8:30 to 10:10 a.m. So the time doesn't change. We're still going to be meeting at that time. Okay. What's changing is we're not allowed to go to the college. Okay. There's the security there. They will push you out of the way. You can go to the parking lot of the college, actually, if you want to get internet, but you can't go inside. Okay. And I can't either, by the way. So I don't have any special priority. I've asked them, when it gets a little bit lighter, will they let me in so I can do webinars on my desk in my office, which is better because my screen's better and stuff like that. But now, this is all we can do. It's not showing me the chat. I always have trouble on this computer with the chat. That's the thing. In my office, I have no problem. So I want to see, are there any new chats? I don't see anybody. Okay. So, oh, I forgot to change the title. This is not statistics, by the way. This is calculus. I think you all know that. I think I did a copy and paste a while back, and I've got to fix that. Okay, so now it really is calculus. It's a 5-unit class, and my name, phone number, you could call, but I don't check my office phone very often. Really, the way to get in touch with me is via campus inbox or email or discussion posts, which we'll talk about that in a bit too. Because again, it's going to be new to some of you. And for some reason, I can't see the chat. I'm looking. Won't give it to me. If it's behind the screen. Okay. So the good news is I've been teaching this so long, and I'm big in technology, and I've always been big in technology, that I know how to do this. Other than I can't see the chat, but I'll get there. So first thing is we are in the webinar, and what we're going to do is I'm going to do this every time. We're going to have Monday, Wednesday, Friday, unless there's an exam, we're going to have a webinar. Real time, because it's a real class. This is different than a regular online class. With a regular online class, I cannot expect students to be there at a certain time, but since you're signed up for this time, I can expect you to be there at this time. So this is the webinar feature that we're using, and hopefully that's not a problem for y'all. I also actually made these a long time ago. Oh, server error. I do have lecture notes. Let's try again. Didn't like it. Let me go find lecture notes. I wonder if our server's down at the college. That's possible. So if you go to lecture notes under my page, and you go to Math 107. And those are lecture notes. Let's try again. There seems to be a dot there, and there shouldn't. I don't know what's happening. Just a minute. I apologize. Stuff happens, especially the first time doing this. So yeah, 107.html. That's what it says. I apologize for this. There it is. Okay, something weird happened. So these are my lecture notes. And I do things, we're doing it in different order because I asked you guys, we're not going to start with the hardest part of this class first. I think that's pretty brutal when we're in this new environment. So I'm switching around a bit, and we're going to start out actually with polar coordinates, parametric equations, vectors, functions, several variables, and then we're going to go to sequence and series. But the lecture notes just in different order. Okay. The other thing is we will use Desmos some, but I want to let you know that in our class, we're actually going into the real world. What's the real world mean that we haven't done much of before in terms of graphing? Like most of your math life, why have you not graphed in the real world?
Hold on. Is it like piecewise more than?
Actually, the real world doesn't have too many piecewise stuff. Most things just move along and they keep going. Any ideas? Okay, in the real world, we live in 3 dimensions. I hope you all know that. So we live in 3 dimensions, but pretty much all of your math life, except a little bit last quarter, everything was in 2 dimensions. Does that sound right? You did the XY plane and you stopped there. Isn't that true? And you never drew farther than the XY plane. But the real world is not 2-dimensional. I hope you all know that. You all know it? Okay, so we need to be able to handle 3-dimensional graphs and really draw them. And CalcPlot 3D, which I was actually part of, I wasn't the main person, but I was one of the helpers, does 3-dimensional graphing very, very well. So we'll get into that, not today, but another day. So the textbook, what we're going to do is we are going to start out, again, because we're doing things backwards, because I don't want to start out with the hardest part. We're going to start out, have it heavy. There it is. This textbook, which is the volume 3 of the calculus book. And I think you all know that I believe in free everything if possible. So it is free online. So you're welcome to pop it in. You just click the link. This better work. If you click that, that'll pop you into volume 3. So we're going to start out with volume 3, and we'll start out with parametric equations, it turns out. And we're going to be doing this today, the parametric equations section. Then the last half-ish of the class, we're going to go back to the book that we did with Math 106 and do chapters 6 and 7. Okay. I think that's a better way to do it in this environment. And you'll see if you'll agree, but you don't need the first part to do the second part, and you don't need the second part to do the first part. So they're very independent of each other, as you'll see as we go. Okay, I'm going to let you read through the course description, student learning outcomes, the prereq. I think everyone in the class is from last quarter. It's kind of weird. Usually I have one or two mystery students who I've never seen before, but this time everyone is a continuing student. Okay, and by the way, I don't know if hopefully it makes you happy, but nobody failed the class. So everybody's back. Okay, so hopefully that'll be true for this quarter too. I hate failing students, and you guys made me smile. So thank you for making me smile and helping you make sure that you all passed. Okay. So some of you chose the incomplete, but you would have passed if you didn't, and then hopefully you'll improve your grade or at least remain stable. I grade the same 90, 70, 60, and then what we're going to do is we're going to have online assignments, same kind of assignments that you had last quarter. Quizzes are different, and I'll talk about those in a little bit because we're online now, but they're only kind of different, as you'll see in a bit. There's going to be an exam 1, there's going to be exam 2, and there's going to be a final exam. Okay, and those are the dates for the exams. Okay, and they're going to happen at the regular time, except for the final, unfortunately, is 8 to 9:50 because we're supposed to use the final schedule for the college, and they throw us back a half an hour. Okay, if we can make it a unanimous call, moving it to 8:30, I can do that for you, but I have to make sure that every single person in the class can make it at 8:30 on that day, on June 22nd. Okay, and as I mentioned, we are not coming back. Okay, do you guys remember the last lecture, actually? The last content lecture I gave last quarter? Remember what it was about? No one remember?
The logistic function?
Yeah, and in particular, what was the application?
Uh, Pandemic spread?
Yep, and I have actually researched this a lot deeper. Um, my guess is you're like me. This is on your mind a lot. But different than me is that you probably don't have quite the advanced math skills to truly change the function as the society is changing. And we have decreased the K in logistics function. And right now, there's a couple possibilities for this. One is that we're going to stay at ky times 1 minus y. Okay, if you remember that, you get a logistics curve. And the problem with that, the good thing about what we've done by staying in our houses, basically, is we're slowing it down. The bad thing is we're elongating it. So according to, if it truly is going to follow the logistics curve, then we're really talking about not coming back to reality until there's a vaccine, which they're talking 18 months. So I don't want to be the bad guy. I'm just a mathematician. And that's what the numbers show. So, but I have a feeling that there's a sine curve associated to this. I'm going to open this one up, this math. Any guess on why there might be a sine curve associated to the differential equation for the coronavirus proportion of people who have it? Again, the math is a little hard, but not that hard. You actually have to know some biology too.
Reinfection?
It's not quite a reinfection thing. It's summer versus winter. It's an annual thing. Is that typically these kind of viruses are really high in the winter, and you probably know that. Like the flu is really bad in the winter, but the summer no one gets the flu. And I think there's a good chance that that's what's going to happen with the coronavirus, is that we're going to have summer off basically, and then winter's going to come and we're back. And then it'll be bad until we have a vaccine. So just be ready for that. Again, I've done the math. That's what it looks like. We're not, by slowing it down, we're not getting rid of it. All we're doing is slowing it. So the only way to get rid of it is with a full vaccine, which we'll get, but they're talking about a while. So be ready for it. I don't want to make y'all cry, but I'm just doing the math. And again, we saw the curve. So one thing for sure is I have been told by the college we are not coming back. So everything will be online. We're almost certainly going to be using Proctorio. I'm not quite ready to go into the details in that because I don't know them yet. I've never used Proctorio because I've always used it. Even for my online class, I used Proctor. So, but we can't do Proctor centers. So we're going to have to do Proctorio, and I'll make it work as good as I can. I'm pretty sure, but I'm not 100% sure, that Proctorio only allows one tab on the computer. If that's true, then I can't do a with calculator and without calculator part. It's going to have to be all without calculator. Sorry about that. If I am allowed to do multiple tabs, then, or with computer and without computer, then we'll have a tab with like Desmos and then a tab for the test itself. I'm still looking into that. No one I asked knows. So eventually I'll find out. But sorry if we're putting suspense now, but we don't have to know until May 1st, which is when the first exam is. Okay, so that's just a note. Then there are the online assignments, and I don't have to say much about them. They're due at 11:59 a.m., so they're due just before noon. That gives you a little bit of time after class to work on them in case you have questions. Okay, then there are going to be in-class quizzes. Remember last quarter we had in-class quizzes? Right? If you don't, then you have no memory because you did that like every single time. So we're still going to have in-class quizzes. Okay, but they're going to be virtual in-class quizzes, and they're going to be time certain from 8:35 to 8:55. Unfortunately, I can't just watch you and see who's done. That's what I did for in-class. With online in-class, I just have to set a time. And I'm going to give you 20 minutes, and hopefully that's enough. They're going to be mostly word type problems. So the idea is it won't help very much to like cheat and go to Desmos or something like that, because you're going to have to kind of read it and understand it and go through. And then they're going to be not multiple choice type things. You're going to have to type in what you're doing and then what your answer is. Okay, if you can't make it to a webinar, you need to let me know at least one day ahead of time, just like before, and then I'll give you an alternate long assignment. Okay, any of you have a different work schedule and now you can't make it anymore? I know that may not be right to ask you guys because you're the ones that are here, but anyone have issues? Let me see if I can get this chat box going. I'm not sure why. Let's try doing this. Ah, there we go. One of your classmates saying he needs a class ID. Now I got the chat going at least. Chat does weird things. I'm gonna do this just a minute. Okay, looks like everyone's okay. Okay, didn't see anything else in the chat. Okay. By the way, one of the good things about Zoom is that you can ask questions. And now I have the chat going. I don't even know what I did, but it's working now. Okay, so you can ask questions if you have any questions to pop into Zoom, and I'm reading the chat now, and I'll be able to see your questions. And you can also talk, and that's fine too. Okay, any questions so far? Okay, so again, those are going to be in-class quizzes. The first in-class quiz will be Wednesday. I don't think it was fair to give you one today. One thing is we haven't learned anything for this class yet, so it wouldn't be fair to quiz you on something. But you're going to be quizzed on parametric equations on Wednesday. And what we'll do is you'll log in. I'll talk to you for a few minutes from 8:30 to 8:35. And then what you'll do is you'll go to Canvas, and then you'll do the quiz. It'll open at 8:35 and it closes at 8:55 is the way I've set it up. Okay. Then there's going to be, this is our first time ever, just because we can't do much with it, is we're going to do an application presentation. Okay. What we have done in the past, by the way, is we did a public presentation on math and physics combination. But because this whole coronavirus thing, we can't do public presentations anymore. We can't coordinate well. The physics doesn't have a lab anymore, so you can't do experiments. But my feeling is there are still applications in calculus that you can still do. And you're going to be working with a partner to work on this application. Okay, and I'll talk about it a little bit today, and then I'll talk a lot more later. Okay, you're going to give a 5-minute Zoom presentation, in which you're going to share your screen. You know, one of whoever your partners are, will share your screen, so you can do PowerPoint or whatever you want to do to kind of show your application and talk through it. And I'll be grading the application both on content and presentation. So it's a group presentation. So everyone has to be part of the presentation. Okay, I have office hours. I have office hours Monday, Wednesday, Friday, right after class. Tuesday from 3:30 to 4:30. And then Wednesday and Thursday from 12. I'm sorry, I should just say Thursday, 12 to 1. Let me fix that now so I don't forget. So that should be Thursday, 12 to 1. And the office hours are going to be using this platform. So that's the best I can do. I can't be in my office because I'm not allowed in my office. And guess what? You're not allowed to go to the office either. So sorry about that. We're going to do our best. If you have a learning disability, then we'll do our best. If you need extra time for tests, we can do that. If you need extra time for the quiz, again, quizzes are lower stakes. They're not worth a lot of points. What I can do if you need it is I can set it so that your particular quiz starts earlier, but you have to let me know that you need it, because no one needed it or no one asked for it for the class quizzes in last quarter. So if you need that, but the exams, definitely you'll get extra time if you have a disability and you need the extra time. Tutoring is different. Some of you might even be tutors. Tutoring happens now online, and I have a link to it. It's going to be at the regular library hours in the Cranian Cafe, and that's the link. You go to it, and then you can get tutoring. Just a note, though, about tutoring. One of the tough things is you're becoming the tutors, which means that it's going to be harder to get help because there's not a lot of people above you in math anymore. And by the way, if you take math next year, if you're here and you take it, then you're the top. And then good luck. You're going to basically talk to me or Bruce, you know, and your classmates, but not for tutoring. For the classmates, they'll just help you. Okay, any questions so far? Okay, so next, the schedule. What I decided to do is I decided to put everything on the syllabus. I have some stuff in the modules, but really the syllabus is where you can find everything. And what I've done is I've set up the schedule, and for each particular day, I have a link to the textbook section, a link to my lecture notes, a link to the homework, and a link to the in-class quiz. So what you'll do, for example, on Wednesday, right after you show up to the live lecture, you'll click on in-class quiz. And again, that's going to be at 8:35. And that'll send you to the quiz to take. And by the way, it's a written quiz. It's not a multiple choice kind of quiz. It's not enter a number quiz. You have to write out all your work. You can write sentences, all that kind of stuff to explain your thinking. Okay. Any questions at all on this? And I have not written the test yet, so there's no link to the test yet, but eventually there will be. Any questions at all on the course? Okay, I want to mention something because again, everything is turned upside down. And because Math Club is a lot of you guys, but we're going to try and do Math Club online. And I'm working with the Boys and Girls Club because I'm actually on their board. And that's a lot of children are at the Boys and Girls Club, and they have a good organizational system. So we're thinking about having our Math Club possibly tutor the Boys and Girls Club kids, which are our kids, I mean our community's kids. And we'll get to you, and Corinne will get back to you if you're in the Math Club about all that, how it's going to work. And again, it just means you can hang out online a little bit, help out kids, and then be offline. So we can't be at the college anymore, sorry. But that's just the way it is. The interesting thing is, had the virus not even existed, we still may be online today. Do you guys know why?
No.
Yeah, not weird. Yeah, I wondered. I have a feeling they would not open the campus. They would have a late start. It's nice and sunny now, but this morning it was pretty snowy. So the good news is that we're good. And the other good news is because we're in a big tourist economy, unlike other cities, our internet's pretty good because we're set up for 1 million tourists, and there's only 23,000 of us in Tahoe. So we're not overloading the system. Okay, hopefully you're all good too with your internet. But that's the good news. So are there any questions at all? Again, I wanted to at least spend the first half hour talking about the course and the syllabus, how it's going to work. And oh, one more thing is that I am going to post these on YouTube. I have my own channel, a YouTube channel, And in fact, I just surpassed, I think over break, over finals week, I just surpassed 1 million views. So that was pretty cool. So what I'm gonna do is I'm gonna post these on YouTube, and then I will have a playlist with the Math 107 playlist, and I'll post that link so that you can view this later if you want to. Okay. But the quiz is real time. Okay, I feel like that should be true, just like I do the same thing with in-class, because this is not an online class. This is a Eve class, which is different than an online class because you signed up for a face-to-face class, which means that you're all supposed to be able to make this time. So I'm teaching it differently than I teach, say, my online class, and I'm also teaching in a different subject, a different course. So any questions before we start doing math? Any questions? Okay, so I have a question for you right here. And here it is. All right, so the question is the following. The graph of the path of one airplane follows y equals 2 minus x. And the graph of the path of another airplane follows y equals x. Okay, assume they fly at the same constant altitude. So x and y are like longitude and latitude, but altitude is constant. The question is, will they collide? I want you to look at it for a while. Let's see if you can talk about it. I'm going to give you a moment. Take a look at it. You can, by the way, it's always a good idea during these webinars to have paper pencil next to you. So you can draw stuff or do some calculations, because I'm going to ask you to do some work. Again, I'm trying to treat this like a regular class in terms of still making you guys think. Okay, instead of just all you have to do is watch and be there and like not even pay attention. So take a look. Will these airplanes collide with each other? I'm going to give you a minute or so. Looks like a very simple question, right? Could ask an 8th grader.
Yeah.
Depends on how fast each one is going.
Okay. Let's say they're both going the same speed.
It depends on where they would start from too, right? Or
Yeah, good. See, you guys are smarter. An 8th grader would all say they collide. Okay. And the point is this doesn't work. It's not enough information to be able to answer a question like this. Do y'all agree?
yeah.
So we need to do this in a better way. What you have done in terms of algebra was not enough to be able to answer a question like this. Certainly, if I go to Desmos and I type y equals 2 minus x, and I'll do that. So y equals, you can probably do this in your head too, minus x, and y equals x. Then it looks like they collide, doesn't it? Okay. Right? Just naively, it looks like they collide, except what if y equals 2 minus x happened yesterday, and it was just a flight from, say, LA to San Francisco, and y equals x happened 10 years ago, and it was a flight, okay, somewhere. Okay, then they don't collide. Do you agree? So the purpose of this is to realize that what we have done so far in terms of graphing, and when I say we, as in y'all for the last, how many years you've done math with graphing, isn't enough. Okay, it's not enough to tell the story of what's going on. Do y'all agree with that? We need to be able to tell the story in a better way so that we can actually talk about time, because it does, as a lot of you were saying, depends on the time. Okay, so the problem is we shouldn't think of y as a function of x, because it's not given the longitude. What is the latitude? That's not what we're interested in. What we're more interested in is where is the plane at this time? Does that make sense? So now I have another question, okay? And this is an algebra question, but I should warn you, a lot of people forget their algebra. What is the formal definition of a function? See if you can type that in your chat box. The formal definition of a function. This is a big deal for not just today and not just all this quarter, but all next quarter also. So what is the definition?
A mathematic? Oh, okay.
See if you can type it, because it really needs to be written. Yeah, let's see if all of you can type the formal definition of a function in the chat box. You all know how to use chat? The little button that says chat, and then you type, and then you hit enter, and then it pops it in. Okay, so we got a few. A mathematical expression that produces only one output for any given input, a relationship between two sets of data in which one set has not repeated values, okay? And then mathematical. Oh, that's just fixing the spelling, I think. That's okay. I don't worry about spelling, by the way. Okay. Each input has one output. Okay, I like kind of what Victor says, but I want to say it in a better way. Okay, I want to focus on those sets. So let's go back. And I want to remind you about the definition. It's really important for what we're about to do. So this is function. A function is a rule that assigns to SIGN to every element of a domain set. A unique element of a range set. That domain's not spelled right. So I really want to focus, because none of you put the word domain and range in your definition, but those are really important words. And for the next, I don't know, several months actually, we're going to be like shifting these domains. Okay, and we're going to be shifting the ranges. So what we're going to be looking at now is parametric equations. So with good old-fashioned functions that you're used to that you learn in eighth grade, okay, or ninth grade, whenever you had it. The domain were real numbers, the range were real numbers, everything was good. You had y equals x, or y equals 2 minus x was a function. For every number, you got another number. But all of a sudden now, we're changing our domain, and we're changing in particular our range. So let's write down the definition of parametric equations. We got small for some reason. Definition of parametric equations is parametric equations are a function from the real numbers to points. So another way of doing that, and now I'm going to have to go to this way, is we're talking about R1. Oh, it didn't give me an arrow. It should have. Oh well, I'll make it an arrow anyway. To Rn. So in this section, we're going to let n be 2. So we're looking at given a number, and a lot of times you think of that number as a time. You're going to get a point in the xy plane. Okay, but let you know we're not going to stick with that. We're going to change that a bit, and we're going to go to a point in the XYZ space eventually. But today we're not doing 3 dimensions, but we're going to move to 3 dimensions. Okay, any questions on the definition of parametric equations? Okay, because you know what a function is. I can use the word function in this definition. And what I've done is I've set the domain to be real numbers, and I've set the range to be points in Rn. Okay, R2 is what we're going to be doing in this section. So the airplane example, there's a lot of different examples, but let me talk about the airplane example. We can have now, when you're talking about taking a number and getting a point out of it, that means if you're given a number, and the letter we almost always use for the number is t. Occasionally you use theta, okay, but most of the time you use t. Any guess on why you use t?
Time.
Yeah, I'd say over 90% of the applications of parametric equations have the domain being time. Okay, the other 10% is usually the domain being angle. Okay, but we're going to be kind of focusing on t for time for now, and we'll do an angle example too, as you'll see. So in that case, what we want to say is, given a time, we need to get an x and we need to get a y. So we need to say that x is a function of t and y is also a function of t. Does that make sense? So here's an example. An example is x of t is equal to 2 minus t squared, and y of t is equal to t. Okay, let's go t squared, actually, even better. Okay, now you look at this, and it might feel like a parabola. I see a t squared there, right? Do you think there's a parabola? What do you think?
I don't think so because it's not on an XY plane.
Yeah, it looks different. You got to be careful about intuition. Okay, well, one way is, and this is not the best way, but it helps on some pieces of it. One way is to go Desmos. So you have 2 minus t squared, and we have t squared. So now let's get rid of these. And the way you do a Desmos, by the way, is you put in parentheses 2 minus t squared, comma, t squared. And let's let t go from, how about negative 3 to 3. Is it a parabola? I hope you can all tell me by looking. Does it look like a parabola?
No.
No, it doesn't look at all like a parabola, right? This is actually a straight line. Okay, it is a straight line, that's it. Okay, so you got to be careful, but here's the thing. When you look at this line, it doesn't tell you the whole story. How come? In other words, if you didn't see the equations and I showed you the line, Could you get the equations back?
No.
Yeah, you can't. And here's what's up. Parametric equations tell you more than the graph after you graphed it. They tell you how you drew the graph. So notice, for example, if t is 0 to t is 1, y only moves 1. But say t equals 4 to t equals 5, y moves 9. Okay, so if you start at 0, for example, then, and in fact, if we start at 0, let's put 0. We started at 0, then you're going to start out drawing it, moving really slow, and then you're going to speed up, actually, as you continue drawing. Okay, and this is really important in engineering because engineers care whether things go fast or slow. They care more, it's not just about what was the final path at the end, but how was the motion? Was it starting slow and going faster? Was it starting fast and going slower? Was it just a constant speed? Okay, was it a constant fast speed? Was it a constant slow speed? Et cetera, et cetera. Okay, and parametric equations are much, much more powerful because they will describe the motion of what I like to call the particle. You have a particle moving in a plane, and you want to say, how is that particle moving? Not just where has it moved. Any questions on the idea of that? So parametric equations give you more information. Okay, what we're not going to do, I know this sounds weird given the class we're in, is we're not going to do any calculus today. Does that sound weird? Okay, for calculus, what questions might you ask?
The derivative or the integral of the function.
Yeah, maybe how fast it's going.
How fast it's going, yeah.
That's the derivative, right? Because I want to be careful now. The derivative is not well defined anymore. You can't just say the derivative. So this is where, starting today, you have to be very careful about how you're thinking about derivatives. Because you might say, well, as it's moving from left to right, how fast is it changing left to right? But that might be different than how fast it's changing bottom to top. And that might be different than just what's its speed. Does that make sense? Those are all different how fast questions. And that's going to happen on Wednesday, by the way. Today, we're going to stick with no calculus, just to get you ready. Because even if you've had parametric equations, my guess for all of you, and tell me if I'm wrong, for all of you, it's been a long time. Am I right? Is there anyone who had it pretty recently? Yeah, I don't think so. Okay, so that's why it's really important if you've had them to review it and to really understand it. Okay, so we actually want to watch it move and not just see where it went. We want to see how it traveled. So the word how instead of where. Any questions on that so far? Okay, sometimes though, you just want to find parametric equations for some geometrical figure and not worry about how fast. Okay, so let's start out with lines. And by the way, there's different approaches to this. Trust me, mine is the best. I know that sounds weird, but it really is, because we're going to be doing lots of stuff with derivatives and integrals. And if you have my way of doing it, life is so much easier for you. So here's the question. Find parametric equations for the line through the points 2, 3 and -1, comma 1. Okay. You know what? Yeah, I'll do these first. I'll do lines first and then functions. Sorry if it's a different order than I told you, but that's not a big deal. Okay, so what we need to do is we need to find an x of t and a y of t. Does that make sense? And here's my big suggestion. Okay, and again, when you look through other books, they don't all start this way, and that's a bad thing. My big suggestion is you have lots of choices for these parametric equations, but there's one that's best. And the one that's best is the parametric equation where you start at the first point at time equals 0. You end at the second point at time equals 1, and you go at constant speed. Any questions on the idea? Because there are an infinite number of answers to find the parametric equation, find parametric equations of this line, but there's a best answer. Okay, so what we want is we want x of 0, I'm going to write it in point form, comma y of 0 to be equal to 2 comma 3. And we want x of 1 comma y of 1 to be equal to negative 1 comma 1. Any questions on this goal here? Any questions? Okay, so now what we're going to do is we're going to think about just something let's go back to the very basics. The line, right? Who remembers the equation of a line? Standard equation.
Y equals mx plus b.
Good. Y'all better know that. Okay. If you don't, you do not belong in this class, right? Okay. Y equals mx plus b. Okay. So we're going to be thinking about that, but now it's going to be a little bit different. Okay. And what's different is the letters. Is what we're going to now do is we're going to say that not y, but we're going to be thinking about this as x of t comma y of t. That's kind of our new y, because remember that our y is the range of the function, right? When you're talking about regular old equation of lines, right? But the range of parametric equation is not a y, it's an x comma y. Any questions on that? Okay, then what we're going to do is we're going to say, well, that's going to be, you could do mx plus b, okay? I think it might be a little bit easier to do the statistics way of doing this. Jada, I see you're in the room. Do you remember how statisticians do equations of lines? Yeah, a plus bx. Okay, and hopefully you're all okay that that's a line also. Okay, so we're gonna be thinking about it as an a plus bx. Okay, but it's not gonna be an x, because x, when you're doing y equals a plus bx, x is the independent variable. Well, the independent variable now is not x, it's t. Have I lost anyone on this? For parametric equations, because we're going from t to x comma y. So we're going to have a. A is the intercept. Okay, I know you call it the y-intercept, but we're not going to be calling it the y-intercept. We're going to be calling it the xy-intercept, because y is the range, and here the range is x comma y. And that tells you when your input is 0, what is your output? That's what the intercept is. Well, here, if your input is 0, the output is 2 comma 3. because we're starting at 2, 3. And then we're going to go plus, and then we're going to have to do our slope. Now, how do you get our slope? Well, it's not the rise over run anymore because it doesn't work that way. Now what you're going to do is you're going to do the change in x, comma, the change in y. The change in x, I'm going to write this out. I know you could do this in your head, but I'm going to write it out anyway, is going to be -1 minus 2. And the change in y is going to be 1 minus 3, right? You take the final minus the initial. That's the change. And then you multiply that. Normally you multiply by x. X is the independent variable, but for parametric equations, the independent variable is t. I want to stop for a minute because I think what I said is a lot harder to understand than what's written down. So I want to make sure you look at what's written down. So it's going to be, the parametric equations are going to be the point that you start at plus the change in x, comma, the change in y times t. Any questions on this idea? Okay, so now what I'm going to do, and I think most of you are in physics, right? Or have taken physics, right? Like last quarter.
Yes.
Okay. So we're going to be thinking of these as vectors. Okay, vectors and points are basically the same thing, right? So we can think of these as vectors. Let me simplify it a little first. I can now do the arithmetic. 2, 3 plus -1 minus -2. -1 minus 2 is -3, comma 1 minus 3 is -2. T. So now we could say, what is the x coordinate and what is the y coordinate? Well, the x coordinate, x of t, now we just pull apart the x coordinates. The first x coordinate was 2 equals 2. And the second piece was -3t. So plus -3t, or right, minus 3t. Any questions so far? Okay, and then the y coordinate, same idea. So we can say y of t will be the y coordinate, that was 3. And then we can say that is going to be plus a -2t or minus 2t. Any questions at all on how this works? Let me ask you, what's the easiest way of checking that it's right? Yeah, plug in 0. That's half of checking this right. Notice if you plug in 0, you get x is 2 and y is 3, and that works. And then what else do you have to do besides plug in 0?
Plug in 1.
Plug in 1. And you get x equals 2 minus 3, which is -1. That's good. And y equals 3 minus 2. And that's +1, and that's good, because that's the points I wanted. Any questions on this? Okay. Now I'm going to say something that's not going to come up till Wednesday, but we can talk about t going from 0 to 1. Okay, because if we go from 0 to 1, then we're actually going to get not the line, but the line segment. Let me write t 0 to 1 gives the line segment. Any questions on that? Okay, the reason why it's going to be important in a few days is we're going to be doing integration. Any guess on what those 0 and 1 are going to be for integration?
Our bounds.
Yeah, there's going to be bounds. And isn't it nice if it's always 0 to 1? So whenever you're doing lines, that always works. And then it's really nice. So we're going to be doing a lot with that. And just to let you know, we'll get into 3 dimensions. I bet you can guess what's going to happen if you're in 3 dimensions. Can you guess what the difference is? The hint is very little. I don't see y'all jumping in. I guess I'll tell you. Instead of X and Y, you can have X, Y, and Z. And nothing really is going to change, just more writing. But the good news is nothing really to do. Any questions at all on this example? Any questions? Okay, so just to make sure you got it, here's a question for you. Find parametric equations of the line that passes through the points 5, 2 and 3, 7. No, it's not. Yes. Let's see if you can do that. Put it in the chat box when you got the answer. Again, I believe in having you guys practice as we do this. That way, if you'll find out if you're really getting it or not. And I'll give you a minute or two. And again, always a good idea to have paper and pencil next to you when you're working on the computer like this. That way you can write stuff out. And this isn't that hard if you know what to do. It's maybe I'll go up a little bit. Not really. I'll check to see if anyone emailed them like, I can't get in, help. Okay, so are you getting it? And again, check your work to make sure you know if it's right or not, because you can plug in and make sure. Okay, it looks like a lot of you are getting it, which is great. I want to ask you, are there any questions now that you got a chance to try? Any questions? All right, I have a bonus question. Let me write down the answer because a lot of you have it, but I want to put it up here so we can look at it. So x of t equals 5 minus 2t. And y of t is equal to 2 plus 5t. So here's a bonus question. Find parametric equations of this line that go in the opposite direction. And the hint is, shouldn't take more than 1 second to do. Yeah, so what we can do, all you have to do is you replace t with negative t. So we can say x of t. I'll even replace it directly. 5 minus 2 times negative t, and y of t is equal to 2 plus 5 times negative t. Any questions on that? And that'll go in the exact opposite direction. Okay, so t equals 0 will still be at that first point, but we'll be at the second point at t equals negative 1. Question?
Can you go up a little bit just so I can see the first problem? That one, the lines. Yeah, there.
How's that?
That's good. I just wanted to take a quick picture and
Oh, sure.
I can go back to it.
Yeah, and if all goes well, this will be recorded.
Oh, cool.
One of the things is I don't trust it because everyone in the world is using Zoom right now and recording. And when I did this during kind of the last recording I did, it took 2 days and it didn't record right because Zoom was overbooked. So hopefully that doesn't happen again. But I'm a little worried about that because everyone in the world is using Zoom right now, and Zoom is not ready for it. So still a good idea to take notes. Okay, at least for a while until we find out if this works or not. Because again, the whole world has gone to Zoom. Okay, any questions? Any questions on this example? All right, now for an easier example. It won't look easy at all, but it turns out it's really easy. This is functions. And let me do it by example, and then I'll just explain in general, but it's easy, that's a hint. Find parametric equations for the line, for the curve, y equals e to the x minus x sine of x. Okay, now you look at this curve, it looks kind of nasty, doesn't it? If I asked you to draw the curve, that's a pain, right? With a lot of work, you could probably do it. With Desmos, you do it in a minute. But if you had to do it on paper, but it turns out it's really easy to find parametric equations for a curve that looks like this. Okay, any questions on the question first? Okay, so here's the step-by-step process. Step 1 is let x of t equal t. And step 2 is replace x with t in the given equation to get y of t. Any questions on step 1 and step 2? All right, so here's what we do. Tell me, what is x of t in these parametric equations? What's x of t? So I have to get parametric equations. What is it?
T.
T. And y of t is just going to be, there's no way I can do it without using a math editor.
E to the power of t minus t times sine of t.
Yeah, just e to the t minus t times sine of t. And those are parametric equations. You all agree this is like the easiest example you've ever seen, or one of the easiest? There's nothing hard to do. And that's it. So whenever you have a function and you want to get parametric equations that also give you that function, this is one choice. Are there other choices? The answer is yes, there's an infinite number of choices. Let me give you, I'm not going to write this down, but just to give you an idea. I could let x of t be t to the 5th power. And then y of t equal e to the t to the 5th minus t to the 5th sine of t to the 5th. And that'll give me parametric equations for it also. Okay, so there are many, many, many different choices for parametric equations of functions, but this is the easiest. Any questions on this example? I think this is easy enough that I don't have to like waste your time and have you try an example. Do y'all agree? Okay, so now let's do circles. Okay, and I'm going to start out with the easiest example. What's the easiest circle there is?
The unit circle.
Yeah, and not just the unit circle, but the unit circle centered at the origin. Do y'all agree? There's lots of unit circles, but the unit circle centered at the origin is definitely the easiest. So I'm just going to write that down. And hopefully you remember the equation of the unit circle centered at the origin. X squared plus y squared equals 1. And what I want is I want parametric equations to this. So we want an x of t and a y of t that give this to you. And the key on this is trigonometry. So do you remember when you had the unit circle centered at the origin and you wanted to say, how did you find x and how do you find y? What did you do? Do you remember?
You could draw triangles.
Could do that, but I like Victor's idea. X is equal to the cosine and y was the sine. Do you remember this from trig? So I can say that x of t, whoops, got folded, x of t is equal to the cosine of t. And y of t is equal to the sine of t. And do you agree that if I plug it in, it works? Cosine squared of t plus sine squared of t equals 1? Hopefully you all agree. If you don't know that, then you probably don't belong in calculus, right? Cosine squared plus sine squared is 1. It's the most important formula there was in all of trigonometry. Okay, so that's really, really important to know how to do this. So now what we're going to do is, this was the easiest example of circles. So now let's adapt. And let's say, well, what if we had, instead of the unit circle centered at the origin, what if we had the center of radius 3 centered at the origin? So let's get that one out. Now, if you remember, that was x squared plus y squared is equal to 9. All right, so now what we need to do is we need to adjust this so that we're going to do trig, but if I let x equal cosine t and y equal sine t, that doesn't work because x squared plus y squared is not 9. So how do I adjust it? Any thoughts? What should I let x equal to?
3.
3, but I like Eli's full example, which is 3 cosine of t. Okay, if you just let x equal 3, then x never moves, and you won't get a circle. But if you let it be 3 cosine t, so if we're going to say x of t is equal to 3 cosine t, and y of t is equal to, hopefully you can all guess what y of t is once you know x.
3 sine of t.
Yeah, 3 sine of t. Then you'll notice x squared plus y squared equals 9, and it works. Because if you take 3 cosine t quantity squared, that's 9 cosine squared. If you take 3 sine of t quantity squared, that's 9 sine squared. You factor out the 9, and you get 9 times 1, and that's 9. Any questions at all on circles? Okay, now I'm not going to do another example of a circle centered at the origin, but if the radius was 25 or something, if it was x plus y squared is 25, you do the same thing with a 5 instead of a 3. Hopefully that's obvious once I show you the one example. There's nothing too fancy about that. Okay, is that all circles that you could ever get? Does that give you every circle example?
No, there's also circles that aren't centered on the origin, and ones
Exactly.
with a bigger radius or a
Exactly.
smaller radius.
Right. Well, bigger and smaller radius, we've done those. Well, like I said, once you know how to make that 3 happen, I hope whatever the radius is, you can make that happen too. Do you agree?
Yeah.
Yeah. I mean, I didn't do it in general, but hopefully you can generalize if you need to. But not centered at the origin, we got to deal with that. So we need to figure out, first thing, let's remember what it looks like. So if it's not centered at the origin, we give an example. X minus 2. Whoops, let's put in math characters. So x minus 2 squared plus, how about y plus 1 squared equals 1. Okay, so now we have a unit circle not centered at the origin. By the way, let's see if you guys can tell me. What is the center of the circle?
2, -1.
Yeah, 2, -1. So don't forget the sign switch when you look at the center. Might have been a while since you thought about this, so I figured I should remind you. And now what we want to do, again, today's all about parametric equations, is we want to say, how do we find the parametric equations for this circle? And the answer is it's really easy.
I'm thinking we do the same thing with t as we did with x and y.
You just put it all in parentheses.
It's a good thought, but that won't work.
Oh.
Okay. It turns out really easy. You have to know what to do. Yeah, you have to remember that what this is a shift. So as Victor says, these are just shifts. So it's going to shift the x, I'm going to shift the y. So notice x is shifted 2 by the x minus 2. Do you see that? So if x is 2, you get 0. So what we can do is we can say x of t is equal to, well, we need to shift it by 2, right? We need to shift it by 2. So what are we going to do?
Did you just write cosine of t minus 2?
Except it's the other way around because we're shifting to the right.
Oh.
So I write it as 2 plus
Oh, I
cosine
see.
of t. And the way to check that this is going to work is what happens when you take 2 plus cosine of t and subtract 2? What are you left with? Right? Because we want x minus 2 when we're plugging in. So if we have x minus 2 and x is 2 plus cosine t, if you subtract 2, you get cosine t. Do y'all see that? And similarly, y is equal to, so now we're going to say -1 plus sine of t. Any questions on how I came up with this equation of the circle? Any questions at all on that? Not too bad. Let's see how
So
you
if the radius wasn't 1 and it was like 9 or something, would we all just put it outside and like out of a parenthesis?
I'll let you
in
figure it
front of
out.
all of that?
Guess what I'm about to do.
Oh, cool.
So what I'm going to have you do. Question. Find the equation. Find the parametric equations of the circle. X plus 3 squared plus y minus 4 squared equals 25. Let's see if you can do that. Give you a few minutes. Okay, so let's take a look. And it looks like at least those who typed in the chat box, you got it. Okay. And I like to look at this, at least geometrically, and realize what you're doing is you're taking the unit circle, you're making it bigger, and then you're expanding the plane. Okay, which is different than, you're making it bigger and then you're shifting. So you're expanding the plane and then shifting. By the way, that's different than shifting and then expanding the plane. So that's important in terms of the order. So what that means is we're going to do x of t is equal to, well, the shift is by -3, and then plus And then we're going to have a 5 cosine of t. And then we're going to have a y of t is equal to 4 plus 5 sine of t. Any questions at all on this example? Okay, and again, I'm not going to do every possible example, but my feeling is that this gives you an idea of every possible example. They all look like this. Any questions so far? Okay, next, what if we did the following? Find the parametric equations of the ellipse. And let's do it. It'll work. Ah, it didn't. I'm not used to using the Google for this, so I'll have to play around. I think there's a division thing. All the snow from my roof just came down at once. That was scary. All right, well, I should use the division thing. So sorry about that. X squared over 4 plus y squared over 9 is equal to 1. Now, hopefully you remember that's an ellipse. It might have been a little while since you thought about ellipses, but they come up a lot. And the problem is you can't just let x be cosine theta and y equals sine theta, the 4 and the 9. So the way I like to think about ellipses is they're kind of like circles with 2 radii. Okay, whereas circles have the same radius for x as they do for y, ellipses have a different radius for x than they do for y. So what I'm going to do is I'm going to let x of t equal to 2 times the cosine of t, and y of t is equal to 3 times the sine of t. Any questions on that? Notice if I square x, I get 4 cosine squared, but then if you divide by 4, the 4's cancel, you just have cosine squared. And similarly, if I square y, I get 9 sine squared over 9, and that just cancels to become a sine squared. So then it works, and I get cosine squared plus sine squared is 1, and I smile. Any questions on finding the parametric equations of an ellipse? Okay, these aren't too bad, but there's a lot of details here and there to deal with. Okay. Let me do the next idea. I did that on purpose. I need to finish the string. Because what I want to do is I want to take this glass, I want to roll it. So now think about, riding a bike or driving a car, and what you want to do, let's say you have a label on the tire. And what you want to do is you want to say, what is the equation for the path of the label as the car is moving? Any questions on the question? Any questions on the question? Okay, now that's a tough one. So what you think about is the key on this, let me write this down. Let me write example. Question is that you have to do. But that would be too hard for me to just tell you to go find the equation. This is called a cycloid, by the way. Find the equation of the path of a point on a tire that is moving along a flat road if the radius of the tire is, let's just say 1 to make life easier, and the tire is moving at 1 revolution per second. Any questions on the question? Can you kind of imagine this happening? Okay, so what you do is, let's do the easy one first. What do you think the easy one is? X or Y? Okay, it looks like a sine, but it's not a sine curve, it turns out. Okay, it turns out X is not the easy one. Any other guess? Yeah, Y is the easier one. Okay, because if you think about Y, that's just going up and down, up and down. You see that? Whereas the X, it's going to go fast if you're at the top of the tire, and it's going to like maybe go backwards or slow at the bottom of the tire. Can you imagine that happening? So X is going to be a little more confusing than Y. Y is really easy because Y is just going around up and down, up and down. And so let me just write down Y of t. I'm going to leave some space and then pop it in. So Y of t is what we're used to. Okay. And that, except we're going to do a shift. 1, and then it's going to be a minus cosine of t. Okay, first thing 1, because what we want to do is at time 0, we want to let y be 0. Makes life easier to understand. And if you plug in 0, you get 0. And then it's a minus because what you do is you start by going down. Right, you're going backwards. Okay? If you think about it, tires rotate clockwise, not counterclockwise. Does that make sense? You're looking at a car. That's why it's a minus. So x of t is going to be similar because it's going to go kind of moving along the tire. So if the car isn't moving, but let's say you lifted the car up and you just spun the tire, then you're just going to see a 1 minus sine of t. Or actually, you can see a sine of t. So you can see a sine of t, but it's traveling also. So you can have a linear part, and that is the car moving forward, and that's just going to be t. And then you're going to have the traction pulling on a tire, and that's going to be a minus sine of t. And I think it helps to actually see it. So I'm going to go over. Let's do this. T minus sine of t. And 1 minus cosine of t. And let's let t go from 0 to 20 or something. And let's go here. And I'm going to do the following. Weird things happen if you just change one of them. That's if it's going really fast. Do you see what just happened? Wait, no, I need a 5t. That's better. No. Yeah, that's if it's going really fast. Let's see. What I want to do is I want to change the domain so you can see what's going on here. There we go. So I want the x. Let's go 0 to 50. Better. Now, does that make sense? Is that how it should look? Okay. All right. I don't have too much time left. I want to do a couple more.
Could you explain
Yeah.
one more time why the sine and cosine swapped x and y position?
You could go either way, it turns out. Typically, you swap. If you swap the sine and cosine, it's still going to go in a circle. I don't know if you thought about that. But
No,
what
that
it
makes
does,
sense.
it changes the direction. It makes it go clockwise instead of counterclockwise.
Okay, that makes sense.
It's that switching direction thing. And that way we're starting in a different place. But that's the idea. Okay, but I only have a few minutes. I want to get to this. Okay, so what if we had x of t equal t plus 5 and y of t equal, let's go t plus sine of 2t. Do the following. There we go. So the question I have is write this as a function of y in terms of x. In other words, get rid of the t. It's called eliminate the parameter. Parameter. So we don't want any more t's. And the way you do it, it's pretty easy. You just solve for t. And you can say that t equal x minus 5. And then you just plug it in to the y equation. You say y is equal to x minus 5 plus sine of 2 times x minus 5. And I've eliminated the parameter. There's no more t. Can this always be done? What do you think? Yeah, not always. Because the problem is we had to solve for t in terms of x, and you can't always do that. So if I changed it very slightly, instead of just 5, how about 5e to the t? Then you're going to have a lot of trouble getting t by itself. Do you agree? So just a note, eliminating the parameter does not always have a true answer. Does that make sense? Okay. One last little thing. I'm going to go a couple minutes late, but you guys can handle 2 minutes. I want to get back to the original problem. Okay. Let's suppose example happen. We have 2 planes. And the first one is x of t equal t, and y of t equal 2t plus 1. And the second one is x of t. Sorry, that's not one on. Going too fast is a problem. There it is. Oh, and x of t is 2p plus 1. And y of t is 4t squared. And then the second equation, I'm going to have x of t is 3t. And y of t is also 3t. So the question is, A, is do they intersect or do they crash? And B is, do their paths intersect? Do you understand those are different questions? Any questions on the question? Okay, how do you find out if they crash or not?
Do they impact at the same time?
Yeah, so is there a given time t that has the same x and the same y coordinates? Does that make sense? So what we can say is if that's true, then t is equal to x over 3. Hate when it makes it capital. There we go. But we also have that t is equal to x minus 1 over 2. Any questions on that? If that's true, then x over 3 must be equal to x minus 1 over 2. Do you all believe that? I can multiply by 6 and get 2x is equal to 3x minus 3, or x equals 3. But that means if x equals 3, then t is 1. Because t is x over 3 and 3 over 3 is 1. But if t is 1, then look at the y coordinates. Then for the first plane, y is 4 times 1 squared, which is 4. And for the second plane, we have y is 3t, which is 3. So do they crash? Yeah, so Victor, hopefully you change your mind. Good. Yeah, they don't crash. You see that? Because there is not a time that gives you the same x and y. Because if there was a time that gave you the same x and y, well, the only time that gave you the same x was t equals 1, but at t equals 1, you get different y's. Okay, how do you tell if they intersect? It's different than do they crash. So then what you have to do is you say, are there 2 times where x and y are the same? Does that make sense? Okay, so now the t's can be different, and that changes everything. Does that make sense? So to find out if they intersect, what we can do now is we can think of the first t being, say, a, and the second t being b. Then we're going to have x is equal to 2a plus 1, and y is equal to 4a squared. And then we also have x is equal to 3b, and y is equal to 3b also. So notice that second set of equations give you x equals y. So if you plug in x equals y into the first, then we could say 2a squared plus 1, or 2a plus 1, is equal to 4a squared. Okay, and that has a solution. Okay, turns out it's you can use the quadratic formula, and you can get it. Okay, we're kind of out of time, so I just want to make sure that you understand. You know, this is. And so yes, their paths intersect, but the planes do not crash. All right, I went a little over because I'm still kind of figuring this whole thing out. And again, we're going to play it by ear. And by the way, again, this is totally new to me. Not teaching online, but teaching calculus online. If you have suggestions, let me know. What I'm going to do is I'm going to stop the recording.